Because it has anomalies. It moves on a trajectory that is very unusual, is aligned with the orbit of the Earth around the Sun, and it will get extremely close to the inner planets, like, for example, Jupiter, Mars, or Venus. It will arrive closest to the Sun when the Earth is on the opposite side, so we won't be able to look at it. You know, the chance of this trajectory is less than 0.2% to be aligned with the orbit of the Earth around the Sun, less than 1 part in 20,000 to arrive so close to the other planets. And one wonders, could it be a design trajectory?
The solar system has a new visitor, and this one is absolutely massive. Now designated 3I, Atlas, it is the third confirmed interstellar object. Its orbital eccentricity is well above 1, which means the object is passing through our solar system once and escaping back to interstellar space for good. Detailed photos from the Vera C. Rubin Observatory have revealed that 3I Atlas is roughly 7 miles wide, making it the largest interstellar object ever detected, dwarfing Borisov, which was 0.6 miles wide, and Oumuamua, which was 0.2 miles wide. A team of scientists has found that the object is teeming with water ice along with a mixture of organic molecules. Spectroscopic snapshots taken with the NASA Infrared Telescope facility in Gemini South reveal strong signatures of water ice mixed with carbon-rich minerals and silicates. The water appears chemically pristine, lacking the heavier isotopic fingerprints typically baked into comets formed inside our solar system. Models suggest this water could have frozen into the comet as far back as 7 billion years ago, well before Earth existed. This means that 3I Atlas preserves a record of a completely different planetary nursery, offering us a literal taste of another star's protoplanetary disk. These new findings strengthen the case that 3I Atlas is a comet, not a covert spacecraft from an advanced alien civilization. Or does it? The object is hurtling toward the Sun at nearly 130,000 miles per hour. It slices into the inner solar system on a steep retrograde path. Astronomers have pinned several key milestones to their calendars as this visitor races through our cosmic neighborhood. On October 3, 2025, it will make a Mars flyby. Just after sunrise over Valles Marineris, the comet will plunge past the red planet a mere 18 million miles away. From orbit, Maven and Tianwen-1 will see its dusty coma start to glow faintly pink in the Martian dawn. On October 29, 2025, perihelion occurs. 4 weeks later, 3I Atlas will sling behind the Sun, skimming to 1.36 astronomical units, about 130 million miles from the photosphere. Here its speed peaks near 152,000 miles per hour. At this point, the comet is lost to Earth-based telescopes hidden by solar glare. But spacecraft on Mars and ADL-1 will keep watch as jets of vapor erupt from the freshly warmed crust. On December 19, 2025, it will make its closest approach to Earth, passing at a comfortable 170 million miles. Too far for a naked eye view, but close enough for the James Webb Space Telescope and the Rubin Observatory to analyze its coma for isotopic clues. On March 16, 2026, it will pass Jupiter, flying 33 million miles above the gas giant's clouds. If NASA approves a late-course tweak, the Juno spacecraft could swing out to sample the comet's dust stream, providing our sole up-close look at material that formed beyond the Sun. After that, 3I Atlas will curve back into interstellar space, leaving behind terabytes of data and many questions. Yet even before the dust has settled, literally or figuratively, some scientists are asking a far more unsettling question. Could 3I Atlas be a piece of possibly hostile extraterrestrial technology in disguise? Remember Avi Loeb, the professor of astrophysics from Harvard, who first suggested that Oumuamua could be an alien spacecraft? He is back again, and this time he has co-authored a paper with his colleagues titled, "Is the Interstellar Object 3I Atlas Alien Technology?" In this research, he notes that the comet's generous size could easily conceal sophisticated instruments. He also invokes the dark forest hypothesis, a scenario where advanced civilizations hide their presence for fear of predatory rivals. Loeb suggests 3I Atlas might be a disguised probe passively mapping or eavesdropping on our solar system. He points to its unusually high inbound speed and near retrograde inclination as possible engineering choices rather than mere coincidence. He also notes that 3I/ATLAS's path swings improbably close to Venus, Mars, and Jupiter, an alignment that could be intentional. An unusual fact about its trajectory is that it comes very close to the inner planets other than Earth, like Jupiter, Mars, or Venus. The chance of that happening is extremely small. Only 1 in 20,000 cases would end up with such close proximity to these planets. He says the idea of alien civilizations sending their own galactic explorers isn't a stretch. Humanity has already sent its own interstellar probes. Voyagers 1 and 2 have officially left the solar system, and Pioneers 10 and 11 are not far behind. He also argues that 3I, Atlas reaching perihelion on the far side of the Sun, could shield both the object and any devices it might deploy toward Earth from close scrutiny. Loeb estimates that given its current velocity, 3I Atlas would have breached the solar system's outer fringe about 8,000 years ago, coincidentally around the time humans first developed the means to record their own history. He leaves unstated what significance, if any, he draws from that timing. Meanwhile, his collaborators point out that the object has yet to display the usual signatures of a comet. Spectral scans have not detected the volatile gases, such as cyanogen or diatomic carbon, that typically linger in a comet's coma, so its true nature remains unsettled. Could 3I Atlas actually be alien hardware? Most experts say no, it's just coincidence. The path it takes through the solar system has a perfectly natural explanation. It is behaving like a regular comet, one of the primordial building blocks of planets made of dust and ice. When it gets closer to the Sun, sunlight warms the ice, which sublimates directly into gas and pushes the dust off. Since the object was first spotted, astronomers have gathered a growing stack of observations, and nearly all of them point to an ordinary comet. Images and spectra reveal the sort of dust jets and faint coma we expect when sunlight warms an icy nucleus. As for the missing volatile fingerprints, gases like cyanogen or dicarbon that glow when a comet gets closer to the Sun, it's simply too early. 3I Atlas is still well out in the cold. Few comets advertise those gases until they dive deeper into the inner solar system. Over the next few months, as it heats up, those telltale emissions should appear if it is indeed an icy wanderer. From images, we also saw that this object is active, which means there is some coma around the nucleus, an indication that this object is in fact a comet. That sets it apart from Oumuamua, which showed no signs of outgassing at all. In fact, 3I Atlas appears more like Borisov in behavior, and that raises an unsettling question. If 3I Atlas and Borisov follow a familiar pattern, then why did Oumuamua break it? How did it just fly past us without anyone noticing until it was already leaving? The detection of 3I Atlas makes Oumuamua seem even more alien. On October 19, 2017, Pan-STARRS 1 was scanning the night sky. At 1:22 Hawaiian Standard Time, a sliver of pixels dashed across the frame, noticeably faster than the usual background clutter. A few hours later, at a workstation in the University of Hawaii's data center, astronomer Robert Warwick scanned those images and noticed a streak racing faster than a space rock should. The object was clocking an inbound speed of 26 kilometers per second and had an eccentricity of 1.20. Its path was an escape ramp, a trajectory that would swing past the Sun once, then fling back into space, never to return. In the next 24 hours, the object received its first name, C2017U1, on the assumption that it must be an odd comet. But the very next day, follow-up observations showed no cometary tail. So the C was struck out, and it became A2017U1. However, even the asteroid label didn't hold for long. The International Astronomical Union created an entirely new class, I for Interstellar, and the visitor was officially named 1I/Oumuamua, Hawaiian for Scout. Astronomers realized that the object was moving away fast, fading beyond 24th magnitude, and they had barely 40 days to measure and learn what it was before it disappeared. The visitor was speeding in from the general direction of the star Vega in the constellation Lyra, the same patch of sky our solar system is drifting toward. At its closest approach to the Sun, it dipped well inside Mercury's orbit, just 38 million kilometers away, then swung outward on a mirrored curve. Backtracking that path through stellar maps is like trying to trace a single raindrop to the cloud. After tens or hundreds of millions of years of drift, gentle tugs from passing stars and galactic tides had blurred the trail. It is possible that in the turbulent youth of a distant planetary system, migrating giant planets hurled the fragment into interstellar space, where it drifted for ages until, by sheer luck, it crossed our neighborhood in 2017. Or is it? Photometry collected by multiple observatories around the world showed that every 7.3 hours, the object's light surged almost tenfold, then faded just as sharply. Such wild swings point to a body that's either extra long or extra flat and tumbling end over end, like a cigar or perhaps a saucer seen edge on. No telescope has ever resolved the object itself, so both shapes remain possible. Then came the biggest shocker. When the European Space Agency traced its path past one astronomical unit, Oumuamua was found to have gained a sudden acceleration. The nudge was small, about 5 millionths of a meter per second squared, yet it showed up clearly in every data set. That level of acceleration would normally point to comet-style jets, but any outgassing should have left a visible dust or gas cloud. Instead, every telescope saw a perfectly clean trail. No dust, no vapor. Solar radiation pressure at that distance is far too weak to produce such a push, unless the object has an extraordinarily high surface area to mass ratio, as if it were an impossibly thin sheet. No natural process can create something hundreds of meters across, yet thinner than a sheet of paper. So what were we looking at? To investigate, NASA turned its Spitzer Space Telescope toward Oumuamua for 30 hours. Spitzer can detect the warm dust of ordinary comets a few kilometers across, even beyond 2 astronomical units. But on Oumuamua, it found nothing. No thermal glow at all. Instead, Spitzer's data added more to the mystery, revealing that its surface is at least 10 times more reflective than the carbon-rich crust of typical comets. Could its surface be metallic? In late 2018, Harvard's Avi Loeb and his team ran the numbers in a paper for the Astrophysical Journal Letters. Since no known natural process makes something like this, Loeb proposed a startling alternative. Perhaps we were looking at artificial light sail technology, a derelict probe or piece of spacecraft sent from another star. Their bold hypothesis lit up headlines around the world. Some hailed it as open-minded science, others dismissed it as sensational. Meanwhile, 2 scientists, Darryl Seligman and Jennifer Bergner, stepped in with a more grounded alternative. They suggested that when water ice sits in the cold depths of space just a few degrees above absolute zero, cosmic rays can crack hydrogen molecules free and trap them in tiny pockets. Over millions of years, an ice chunk becomes a hidden hydrogen reservoir. As it warms above about 40 Kelvin during a close pass by the sun, that trapped gas seeps out like an invisible jet, nudging the body forward, yet leaving no dust, no carbon dioxide, and no heat signature for our infrared telescopes to detect. They coined these stealthy objects dark comets. This theory accounts for the unexpected push in the spotless trail, offering a natural explanation rather than an artificial one. Since their study, astronomers have uncovered a growing family of these stealthy bodies within our solar system. All share the hallmark of dark comets: measurable outward jet forces with no dust or gas detected, implying invisible volatile-driven thrust. However, Avi Loeb has remained publicly unconvinced by the dark comet idea. In a series of essays and follow-up papers, he has argued that the hydrogen ice model miscalculates how the surface cools as hydrogen escapes, and that the required outgassing would still leave detectable effects. In Oumuamua's case, he continues to press for a radiation pressure-driven light sail instead. So how do we settle this debate? Enter Project Lyra, a blueprint sketched by the Interstellar Probe Working Group. Their vision is to launch a small probe around 2028 aboard a Falcon Heavy or Starship, sling it past Jupiter for a gravity boost, then dip it close to the Sun for an Oberth burn, harnessing solar gravity like a slingshot to send it on a 20 to 25 astronomical units per year trajectory. In theory, that craft could catch up, but not until the 2050s, when Oumuamua will be 200 to 250 astronomical units away and fainter than magnitude 35. Pulling off such a mission would mean mastering heat shields to survive the solar dive and propulsion systems more powerful than anything we've ever flown. It's a long shot, literally. Or there's another way. Rather than chase a fading target, many researchers prefer to ambush the next visitor. And this time, we just might have. While Oumuamua defied all categories, no tail, no visible gas, no thermal emission, 3I Atlas appears more familiar. And that's exactly what makes it so important. By comparing these two cosmic outliers, astronomers now have a real chance to separate what's strange from what's typical. Whether 3I Atlas is just another icy wanderer or something far stranger, one thing is certain: it's a visitor from a place we may never see again. Every image, every reading could be a once-in-a-lifetime clue about the mysteries beyond our sun. If you want to follow its journey and uncover more stories, space doesn't give up easily. Make sure you subscribe to The Unknown. Our next discovery might change how you see space forever.